Welcome. This lesson is the first in a series about the X-ray beam. Radiographic images are created by exposing the patient to an X-ray beam. The X-ray beam is actually composed of millions of individual X-rays. So what is an X-ray? An X-ray is simply a tiny package of energy that we call a photon. That's why sometimes we refer to it as an X-ray photon. X-ray photons have a lot of energy, but they have no mass, they have no charge, and they travel at the speed of light. Their velocity never changes. X-rays are actually similar to light in some ways because both visible light and X-rays are part of the electromagnetic spectrum. The electromagnetic spectrum is the entire range of photon energies, and this includes some familiar terms. Radio waves, microwaves, visible light, X-rays, and gamma rays are all part of the electromagnetic spectrum. So these terms are all referring to photons. The only difference is the energy of these photons, which is controlled by the wavelength and the frequency. Wavelength and frequency are not complicated ideas. The wavelength is simply the measurement from one peak to the next peak. When we're talking about X-ray photons, the wavelength is commonly measured in nanometers. When the peaks are closer together, the wavelength decreases and the X-ray photon has more energy. But when the wavelength decreases, something else also happens. The frequency increases. This is the number of wave cycles per second measured in hertz. In this particular wave, the frequency is about 2.5 cycles per second. Both the wavelength and the frequency affect the energy of the photon. You can think of it like this. Both of these photons are traveling at the exact same speed. And for all photons, this is the speed of light. The only difference is the wavelength and the frequency. The upper photon has a very long wavelength, therefore it has a low frequency and very low energy. The lower photon has a very short wavelength. This results in a higher frequency and therefore high energy. So here's the general relationships that we need to understand. If the wavelength decreases, in other words, if the peaks of the wave get closer together, the frequency increases. That means there's more wave cycles per second, and the energy of the photon increases. Notice how there's no change in velocity, simply changes in the wavelength and frequency, and that's what influences the energy. Of course, the opposite is also true. If we were to increase the wavelength of the photon, the peaks would be farther apart, the frequency would decrease, and therefore the energy of the X-ray photon would decrease. So here's the thing about an X-ray beam. It's not made of just one energy. The X-ray beam is what we call polyenergetic, and that just means there's lots of energies. There's millions of photons in the X-ray beam, and all of these photons have a wide range of energies, some high and some low.